In this video, I'll be covering question 2, part C from the 2023 AP Calculus AB free response calculator required portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. So let's dive into C here. So C wants us to find the distance between Stephen's position at t equals 20. Stephen is this swimmer who's got a velocity equation up above, and his position at time t equals 80. And so what you want to do here is you got to sort of be careful. When you see that word distance, you're probably, your gut's originally going to go to this idea of total distance. Total distance and the distance between two things are two different pieces. If you don't see that word total here, you're not doing a total distance problem. When you want to find the distance between these two objects, what you're really looking for is the displacement. How far from your initial point in time, so if you're at t equals 20 right here, how far away from that do you end up displaced? So when we do displacement, displacement treats movements forward and backward and adds them all up. So it treats them as positives and negatives. So it's allowing for the fact that you could have gone forward 50 meters and then you could have come back 30 meters. And so in the end, on a displacement problem, what you'd end up seeing is that that amount there is your displacement. So in this situation, that would have been 50 minus 30 would have given us 20 meters. And so when you want to find out your displacement, how far you've moved from your original position, then you're going to be doing an integral. So it would be the integral from A to B of whatever that equation is, usually a velocity equation. So let's go ahead and say that this is v of t dt. And that's going to give us the displacement from our starting time of A to our ending time of B. So it'll account for all the pluses and the minuses and just give you an added up version of how far you ended up from where you started. So maybe that was t equals 80 right there. So for our problem, we just want to set it up based upon what we're specifically looking at here. So our problem would go the integral from our starting point, which is at time 20, to our ending point, which is at time 80. And then it would be of our velocity equation here. So this would be 2.38 e to the negative 0.02 t sine of pi over 56 t and then dt. That's the setup we need to do, and the answer to that is going to be the answer to this problem. And lucky for us here, we have a calculator required question in front of us, so we can actually answer this pretty quick and easy in the calculator. You're going to take, and in y1 on the calculator, you're going to put that velocity equation there. So this would be 2.38 e to the negative 0.02, and then when we type it into the calculator, you'd replace any variables, t's or whatever, with x's. So that'll be an x times the sine of pi over 56, and again x. So you'll shove that into y1. In step 2, you're then going to graph this. And when we graph it, the key on this is we need to just make sure that our window is large enough to take in those values, those x values right there. If you kind of follow this process, if you go back and start off at part A and work your way through it, in part A, you should have set your window up to match this interval here from 0 to 90. So I would hope that you still have that in there. And if not, I would sort of keep that in there as your window. So x equals 0 to 90, because this is how long Stephen was in our pool for. So we'll graph that, and then from there we will do a second calc, and then in the calc menu we're going to choose the number 7 option, which is integral of f of x dx. The calculator is then going to ask us a series of questions. We'll answer them, and out at the bottom it's going to end up saying integral of f of x dx equals, and whatever that is going to be our final answer. So let's go ahead and open up our calculator. We'll go to our y equals, which is the button in the top left. If you've been following along through the other videos, you probably already have that velocity equation entered into y1 from the previous work we did on A and B. If not, take the time now to go ahead and enter it in. And again, if you've were doing this on the previous videos, before you graph it, you would hit the window button up at the top. You want to set that X min to 0, set that X max to 90, and then, I set the scale because that's where all the tick marks are, but you don't need to do that. That just makes the graph look nicer. Then we graph it, and now we're ready to do a calculation. So we'll do a second calc, and in the calc menu, we'll choose that number 7 option, integral of f of x dx. From there, it's going to ask me 2 questions. The first question is the lower limit. The lower limit is our lower bound, so I'll type in 20, hit enter. It's then going to ask me for the upper limit. The upper limit is 80, so I type in 80, hit enter. It shades it all in, and then at the bottom of the screen, it's telling me my final answer. So the integral of f of x dx equals 23.8. You would round this. When you go for your final answers on the calculus test, you always do it to 3 decimals. In between values, if you're using them, you always want to do it to 6. So this would be 23.384. And then in the end, you just kind of want to answer their question, right? It's like give them that final response. So we would say the distance between Stephen's position at our original time, t equals 20 seconds, and the position at t equals 80 seconds would be, and then you just tell them the number. So 23.384, and then that would end up being meters because we're talking through this in meters per second. If you look back up at your original interval there. So this would be meters, 23.84. If you needed to know, if you weren't sure about the units, remember as you do units is a multiplication game. So this would be whatever the units are from the velocity. For this problem, it was meters per second. The units from our time, which would be seconds. And so in that situation, seconds cancels with seconds, and what you're getting out is that total meters. So if you didn't recognize it from there, you would have wanted to kind of know how to do that. So that's going to be our final answer. That would have been 2 points. You'd have gotten 1 point for setting up the integral at the beginning, and then you would have gotten 1 point for kind of drawing that conclusion with the proper answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.